Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about DIY EDM breakthrough that's happening right now. So let's dive deep into it. So what exactly is the problem? Because few years ago we had this breakthrough with 3D printing. 3D printing went from some technologies that was held behind patents from 1980s. Patent expired in 20 years. So it started to flood into market. Lot of love and effort was put into it, and future is 3D printing. But here's the deal, it is amazing for rapid prototyping. Like, there is no discussion. Bespoke components, meaning if you just want to make one-off thing, it is genuinely good. So while all that being true, it is still not a serious tool, meaning there are certain scenarios where you just, like, you can force 3D printer into it, it just won't be that good. So, and here's the deal, unless you're talking about resin 3D printer, plastic itself is the weak link. For example, if you're like, okay, if I can make this bracket, let's just say, if I can make this bracket from ABS plastic, injection molded ABS plastic, yeah, my problem would be solved. Cool, awesome. Does that mean you can 3D print it? No, not if it's under stress. So, because you have to understand, whenever you are talking about like best of plastic, that simply means isotropic, meaning the whole thing is injection molded and whole of the thing is behaving like one unit. There is no layer, there is no construction, there is no directionality to it. It is a thing. If you have a complex three-dimensional geometry, yeah, there is no discussion. You cannot replicate it via 3D printer. Why? 3D printers are what we call 3D printed layer anisotropic. So it's weak, as in, like, if 3D printer is like that, you're like, tension force is awesome, but here's the deal, in this dimension it breaks apart. Now you can angle it, but again, you created a scenario where it's only strong in this axis, or like basically you are overlapping it. So that's the whole point, meaning if you can get an injection molded part for less grams of plastic, it can give you more strength. So even with plastic itself, it's not the best. It does work for, again, bespoke parts, prototyping, GG, awesome. But it has its limitation against plastic itself. And if you need even milder temperature, high temperature, strength, plastic flat out, at that point, even the best plastic won't be able to handle it. Meaning, if you open your mouth, it's like, I want to make a microwave out of plastic, people will be like, unwise. Let's just put it that way, unwise. You're like, okay, I want to make a gas stove out of, plastic part. Yeah, no. So the moment you are talking about temperature, the moment you are talking about load, like I want to put some load into it, yeah, no. It's just like, no. So there is a serious limitation with 3D printer. 3D printer got us so far, but what's next? Like, how do we go from to dealing with plastic to actually making something that's like, not like a tank, so to say. Like, if you want to make a tank in your house, how do you do so? Well, in comes the EDM. Now, EDM is what we classify as electrical discharge machining. Now, it's a very simple way of saying you zap the material away. You basically zap the material out of existence. So it just uses spark to erode conductive materials away. And yes, that's the conductive, the critical part. As long as it's conductive, it will work. It does not give a damn what that material. It could be tungsten carbide, it could be some type of ceramic, it could be carbon fiber. It does not care. As long as it's conductive, it's like, I got you. It does not care about anything else. Now, EDM does have the one core benefit. That's why it's so precise. It's what we classify as non-contact, as in it's not putting pressure into it. Although ironically, is the EDM cutting part is not putting any pressure on the metal, but the water jet we put there just to flush out the material, cool the material, that's putting force. Like, you still need to clamp it down, not for the, oh, you're cutting through it, you're like, no. It's like, that process is like, no problem. It's just that you're flushing that water is putting some pressure. So that water is like, water jet. And be mindful, these are high pressure water jet. So it's completely what we call non-contact. It's almost like laser. Like, the sheet metal that laser is cutting, it's not fighting back. It's not like CNC where it's like, you're going through it, like action equals reaction. So your machine has to be rigid. If your machine is made out of aluminum, it can easily deal with wood. But if it's like trying to go against steel, steel will fight back and it will destroy the material, as in like the CNC. So you want something non-contact. You can make a laser cutter out of plastic and it can just chew through thick steels, because again, non-contact. EDM can do the same thing. So it's one of the most precise milling technology. The moment you're talking about high aspect ratio, meaning let's say 1 inch thick, because laser beam converge and then diverge, it will not be able to match the precision this puppy can do. This puppy is like, if I say it's 0.0001, it will be that tight. It's tight. So fundamentally, because be mindful, it's also like milling. So you have the ability to do a roughing pass, then do a touch-up pass, then you a shiny pass. And like, oh, by the way, that's how medical surgeon tools are made. So fundamentally, it is precise. Meaning, if you have the gantry that is precise enough, it will make a precise output part because it's not physically contacted. And on a high spec part, there is no technology that comes close to it. Like nothing. Like, don't even waste your time, kind of. Like, don't worry about it. Although you are talking about electric gap, you do need a controlled environment. So we use dielectric fluid. It could be oil. Most of the time, it's a deionized water. Now that water does few things. First, cooling. It is necessary. You are zapping things. So that will create heat. If you do not cool it instantaneously, problem is that heat will start to warp your part. So you need cooling. And another, flushing. You are vaporizing material, just going Thor in their ass. It's exploding, literally exploding, literally going blah, 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 blah. So if you do not have water that is flushing it away, yeah, that swarf will create an issue. Now, only conductivity matters whenever you're talking about this. This does not care. It's like, oh, I'm like tungsten carbide. Or, like, bro, I do not care. It's like, psh. Of course, let that be very clear. It does have to calculate based on the power supply. It will become a headache for power supply. Basically, how much pulses I have to fire, and CNC, how fast the CNC has to move. But if it's any sort of decent industrial system, it does not care. It's like, bro. At best, it will be like, okay, it's a bit slower. But it's like, bro, I got this. I got this. Me good. Oh, be mindful. You must have seen a lot of EDM machine demonstration where they're like, okay, two parts are nesting each other. It looks like it was cut out of each other. No, they're not cut out of each other. I used to think that. But again, no electrode is that small. Even wires are not that small. So what they do, they cut two parts. So the outer parts, they like do a lot of finishing passes, like bring it into tolerance. And the, the negative part, they expand it into the tolerance. So the tolerance is very tight. And again, after that, they mate these two things, they polish it. That's why it gives a feeling that it was cut out of, because like all the polishing marks aligned, so it feels like, oh, it was cut out of the same piece of metal. It's very clever, but you get the point. Like, this is precise. Like, there is no discussion. If you have a good EDM machine, there is not that many things that can exceed your precision. So EDM metal, it does not care. Conductive material, it does not care. Thickness, it does not care. Hardness, it does not care. And it does not apply pressure. So your gantry does not need to be like Thor-like strong or Hulk-like strong. So that's the benefit of it. So how do we construct this magical machine? Well, rather very simple, because again, there is a low force system. You can make out of 3D printing material, as in like if you want to, you can make it out of 3D printed PLA. It's not recommended, but you can if you want to. Be mindful, at that point in time, the plastic squish will be an issue because of the stepper motor twisting everything. So you can make it out of same robustness as you do with your 3D printer. And again, we have mass-produced 3D printer to hell. So that thing is like minor inconvenience. And it does need watertight tub, so to say. So that is a requirement. And if you want to do like a industrial thing, like this is the thing, I'm doing the thing, at that point in time, you do require water filtration, because for most small scale use, whatever you see in DIY community, what they do is pour distilled water and then just wait, because it's too pure at the early stage. Once the first start to gunk build up, conductivity reaches the sweet spot, and hopefully you'll be done before it becomes too conductive. So, but again, if it's a continuous system, like you are doing machining, at that point in time, it's like, yeah, it would be best for you to invest in some sort of water filtration system. And CNC programming does require a bit of tweaking, because like same way, end mills are not designed to bounce back, but 3D printer does, because again, every end of the layer, they pull back the filament. So same thing sort of is required here, but it's in a different domain. Basically, you do not roll back the wire. What you do is basically, let's just say this is the material, you went too close to it, it created a short circuit scenario. The power supply will detect it. Power supply will inform the CNC mechanism. It's like, bro, short circuit, pull back. Now, CNC machine has to figure out what's my last command, roll back. That command is like, it was like this, roll back. So it creates a precise spark gap. And so again, it could happen from this axis. It's like, oh, pull back. So it does require a little bit of finagling, but again, it's minor inconvenience, or you can just open source also. You can just open source it nowadays. It does require a little bit of back feedback loop from the power supply, and certain sort of issues that only a EDM machines has that you have to deal with. And tools are the consumable here. Basically, how a CNC machine looks like, okay, it's a machine going, "Whee," but those are consumable. The "whee" will go away. Like it will wear down very quickly. So any machine shop, they consume those things. They are like buying drill bits by trucks. So not even joking about that. So if it's like a custom machine shop, ooh, they consume those things. So that's a big thing. Here again, you are doing the same thing because you are electrocuting it, you are consuming the tool, but it's super cheap. It's a spool of wire, it's a spool of brass wire. It's not expensive. Not even in India, it's not expensive. Like, it is cheap. So like, you will not feel it. Let that be very clear. Like, the biggest issue would be like the distilled water or the filtration that you need for distilled water. So that is the only thing you're gonna feel. Like brass wire, of course, if you're not careful with it, if your settings are not dialed in, you might break too many of it to be like, cost effective, but it's a minor thing. Consumables are like, nobody cries about it. PSU, that's a bit finicky part. Like, why we haven't done this? Again, only in recent years, like let's just say last 10 to 15 years, we had become accustomed to the idea, hey, you are just a random guy, just a random dude, and you are just like doing your things and just sending the material, and the PCB comes into your house. That's a recent thing, like recent. Now, heck, I have done like 3 PCBs so far. Again, simple PCB, but I have done it. Like, it's a thing that if I want to design something, I can just send the PCB. And again, it's an Indian shop. I'm not sending it to China. It's an Indian shop. So now we have reached a point where this power supply unit, it's something that if you come up with a good design that can be replicated, people will be able to replicate worldwide, in India, in China, in USA, Europe. They can do that. So what does the power supply need? Well, it needs a few things, few unique combination. Combination number one, it does not need to be high voltage. So you're not like 10,000 volt. It's not even mains voltage. Most of the time it's lower voltage. Sometimes as low as like 24 volts. So voltage is not high. Current is very high. Now, again, it's not continuous. It's not like, kilowatts of power consumption. The power consumption is also not that high. But pulse current is very high. As in, like, the pulse that you're putting, that could be few amps. Like, it's a big, like you're lightning to it. So that is there. And how quickly you're doing it, that PWM, that puppy is few kilohertz. You are talking about now combining low voltage, high current, not big deal. Combining all of that while switching it at a kilohertz frequency, yeah, that's tedious. Basically, you need to have good understanding of MOSFET. And I do not mean just like turning on and off at high frequency without creating a feedback loop, without creating any sort of like, backlash where it like fries your board or poofs your MOSFET. So if you can have high enough frequency, high enough current, and low enough voltage, you're good. So voltage and current is not that big of a deal, but switching them reliably, crisply, that's the hard part. And again, you also have to communicate with the CNC part of it, as in like, hey, this is what I'm doing. Because again, this board will detect short circuit, meaning you ground the workpiece and the wire has the positive charge. So if it comes too close and instead of creating an arc, it just creates a short circuit, this will detect, hey, happened. And it has to talk to CNC. It's like, bro, pull back. So that's the what you call non-standard part. Everything else is like, people are not building too much of that. And again, if you really want to fry your brain, look into people who are building high speed 3D printers. You will be blown away. I'm not even talking about tool changes. I'm talking high speed 3D printers. Like, damn, they are building some amazing machine. So why haven't they built EDMs? They could build this puppy 10 times better. That's not an issue. It's just they cannot touch this. This required some very clever people to come up and it's like, hey, it's not black magic. It's just some naughty switching with PWM. So again, kilohertz are not end of the world. Like, you can build kilohertz switching frequency. And if you are good with it, maybe you can build even better than this. That's not impossible. Oh, but be mindful, it does have to have a feedback loop where it's like, if it detects shorts, it does not send pulse even in a short scenario. It has to stop, it has to talk to someone. So it does need more what we call, rather than just like a PWM management, it has to be like, hey, whoa, stop, unback, okay, now start again. Like, it does require a little bit of finagling, but it is doable. So there are two major types of EDM machine. And again, two types of machine you can build. First is, EDM does not apply any force, it's just erosion. That means tool, brass wire, thin tube. Now, thin tube is critical property. If you have thin brass, the electrical spark will like literally push it away. And again, how the heck you make sure it's drilling in the right way? So it has to be pressurized with water. So generally we have two classification, wire EDM, non-wire EDM. Non-wire EDM is called by many names. So you can hear EDM drill, you can hear EDM sinker, you can hear EDM die. I have no idea why die is called die, but it is die. It's just like die. So that is there. Basically non-wire. So if you want to do just like many things require basically sinker EDMs, especially for injection molding. Like plastic injection molding requires very precise control over the mold. So they can make the negative of that from graphite and then they can machine into it. Now, why do that rather than going through CNC? Polish. Like the output just from EDM, like if EDM does like first pass, second pass, third pass, the output you will have is like, and if you do that on hardened steel, which again, you have to do that so it can survive in the mold, there are shops that can deal with that. But they're going to charge you a pretty penny. At that point in time, bro, just buy the EDM machine. At that point, just buy the EDM machine. So, and again, God help you if you're dealing with ceramics. If you're dealing with ceramics, it's like, conductive ceramics, you good. If it's non-conductive, so flat out. That brass pipe allows you to do deep hole. Like somebody was flexing it, like they had M3 screw and they drill through, like it was 40 mm screw. They drill through it. It is impossible to do that on an M3 screw, but they could do that. Like in EDM, it's like minor inconvenience. So flat out, that pipe, it's almost like a syringe. Think in that way, syringe. That's what it is. It gives the rigidity, cooling, flushing, everything, same thing. And custom strips are generally made. So for example, like you want female hex port, how the heck you do that? You can machine it, there are certain systems, or you can just plunge the hell out of it. You can do that. So custom parts and all that. Most of the time, if you're building molds, people generally use those sort of non-wire EDMs, but wire EDMs are also there. But be mindful, these are not 3D. Whenever you're seeing wire EDM, it's not 3D. It's 2D or 2.5D. Basically, 2D is like going like this. It's almost like laser. You do not do too much about it. Or it could 2.5D, meaning you can twist it. You can go like this. So it's almost like how some lasers have like, fixed head and it's like that's 2D, but some laser head can twist, or like water jet nozzle that can twist. So you can do that. That's 2.5D. So wire EDM does have that option. And if you are really going into like very high quality wire EDM that can cut like this, military will start paying attention to you. As in like military intelligence will start to pay attention to you. Why? Here's the deal. How do you think shape charges for boom devices are made? So fundamentally, it is a very, what you call, sensitive topic, because again, there are not that many things that can work on ceramics and fission materials and stuff. EDM is like, bro, I got this. So be mindful. Again, let that be, guys. I'm not talking about cheaper material, but if it's like really good, somehow FBI will get a ping. It's like, bruh, somebody is buying something too good. Of course, if you are Toyota and all that, who cares? But if it's like a random, nobody is like getting that super duper high end EDM machine, people are like, what you doing for? And especially, God help you, if you start to buy basically things like copper. It's like, why do you need such a big amount of copper? Shape charges reuse that. So yeah, and again, there are a lot of parts in boom devices that are made only from this. Like there is not, I have not seen anything else. And be mindful, laser, while it can cut and do all that 2.5D thing, it will not be precise enough. So fundamentally, it is really good. And you can add rotary axis. For example, this, I have linked the video down below. So he wanted to create a hex key. How the heck you do hex with a 2D? Again, add a rotary system. So tada, he can cut a hex key. You can cut an octagon key. Whatever the heck you want to do, you can do that. With just adding one rotation, nothing too magical, nothing too complicated. Just, and it's working on hardened steel. You can't do that easily with any other machine. So as long as you got the power supply, as long as you have decent enough motion stage, things you can do is no longer limited. It's not like, oh, but it's plastic. No. It is the material that holds the world together. Like, oh, I want to make an injection mold. It has to be hard. It can survive at least 1 million injections. It's like, bro, I am the guy. So these are the two types of EDM. Sinking on 2D. 2D can become 2.5D, or you can have rotary so you can cheat into a lathe machine. So DIY part of it. Now SD, let's be very clear, EDM is an old technology, actually a bit older than 3D printing also. So it's old and I'm pretty sure all the patents have expired by now. So it's old, it's easy. It's just that there was no interest and electronics was the weak link. Let me be very clear. The motion stage, if you, again, this is Ender 3. So most people can make it from that. It's not that fancy. It's just that box was the tricky part. So That was the limiting factor. But now people are saying, again, we have reached the saturation of 3D printer. It's like, it's not exciting anymore. Again, you can make fast 3D printers. It's already been done. You can make tool changer, already been. That's the biggest consumer jump that is happening, is tool changer. And there are two companies that are doing some good. Prusa is coming back with 8 tool changers, and Ultimaker or Snapmaker, I keep forgetting, I keep getting confused. Basically, they are coming with 4 tools. That's the only thing that's happening in 3D printer that is like, whoa. But like, we reach the saturation, like not much else gonna change. Yeah, some people are saying we have resin printer that is almost same strength as ABS. Okay, but again, resin is not cheap. So fundamentally, take that same effort, same horsepower people had, dump that into EDM, tada. And EDM has this one advantage. In a one jump, you can go from basically having an EDM machine that is like $1,000 to $2,000 to $3,000, generally less than $3,000. You can go from that to a hard steel machine, because again, if you have motion stage, while you are not applying pressure, you are still getting a reaction from all your stepper motors. Plastic inherently will flex. Again, it's not a big issue, but if you want that 0.000, you need to compensate for everything. Your tool needs to be rigid. It requires steel, not even aluminum. It has to be steel, and certain steels that have like very low thermal expansion and contraction. Those things, EDM is like, bro, I can eat that. That's not an issue. As long as your PSU is like good enough, you good. That's like, you spend time like fine tuning it, done, go home. So in one jump, basically you have one plastic machine, put some effort into it, and tada, now you have a basically full-fledged hard steel chewing machine that can just chew through anything, like flat out anything in one jump. It's no longer like, okay, 3D printer, print a CNC machine that can work on aluminum, then make aluminum CNC that can work on steel. Like, you know, you have multiple steps till you reach a point where it's like, no, now I can do anything. EDM does that in one jump. Plastic, hardened steel, done. Done. So that's a very critical aspect that you have to understand. And PSU is now open source, meaning if you, again, if you're like, hey, I do not want to import it, cool. Most countries you can get your PCB built and again, do manual components, all of that. So that's not an issue. And buy option is also available. HTO filters, yeah, that's a messy thing, not too difficult. Again, more and more enough country have RO industry, so filters are also available. A brass wire, cheap. Tube, brass tube, that especially if you want to drill, those are consumable, but they are sold in packs. It's like, consume it. It's not even a end mill kind of thing, oh, we have only 15 in stock or something like that. Nah, buy as much as you like, buy in tons if you want. It's not the limiting factor. The spool and all that is like, you good. So, and again, now you can, if you go start with this now and you scale up into a proper metal one, now you can work on real important stuff. Like, you want aircraft component, you can make it. If you want like a weapons component, you can make it. If you're like, okay, I'm making this engine part, you can make it. Like, flat out. You good. You got this. And again, be mindful, this has more cost to output ratio than laser. And again, if you have to deal with thick parts, this is like, bro, laser cannot do that. Like, again, it can do that, but if you have 60 kilowatt of fiber laser, I'm pretty sure you would not be watching this video. So, unless you are one of those weird person who has, for some reason, 60 kilowatt laser power, but other than that, there is nothing that can come close to the horsepower. And again, in one jump, you can go from a plastic machine to a machine that is like serious, solid, robust. And you're like, okay, what if the motion is not precise? You can compensate for it as long as it's rigid enough. It has to be rigid. So, like for example, the guy who's making this lathe axis, he found out the lathe axis was like offset. It was spinning like this. Here's it. All he had to do is like use the EDM machine itself to probe it. So he probed it, rotated it, probed it again, and it created a CAD model, so to say. And he then created that offset. You do the same thing in your 3D printer where you have that bed probe. It probes everything, creates a reality map, and then compensates the model for it. So flat out, it is a big deal. Like, many people are sleeping on it and it's not getting the attention that it needs. But trust me when I say this, from an engineering point of view, like, if you really want to do things, this machine can change the game in one jump. Like, one jump, maybe a month to 2 months of elbow grease, you can have something serious, like serious. So this was a presentation on this breakthrough that we are almost pushing through, where EDM becomes the next thing. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.